Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning. Today, inshallah, we are going to talk about a very nice topic, which is balancing a chemical equation. Why we balance a chemical equation? And how can we balance a chemical equation? Let's watch together the following presentation. Balancing a chemical equation. At the beginning, balancing a chemical equation, in fact, is an application for the law of conservation of mass. The law which says that mass of matter is conserved. Mass of matter is remaining constant. It doesn't change. The mass entered a reaction is the same mass as produced from the reaction. The total mass of reactants must be equal to the total mass of products. This is what we are going to apply when we are balancing a chemical equation. As you see now, for an example, the number of atoms of each type of element must be the same on both sides, on the reactant side and on the product side. So if we have 2 atoms in the reactant side, we must have 2 atoms in the product side. If we have 4 atoms in the reactant side, we must have 4 atoms also in the product side. Now, let's watch together. Hydrogen and oxygen gives water. This is a word equation. If we convert it to a symbolic equation, it will be H2 plus O2 gives H2O. Hydrogen and oxygen are diatomic elements. This means that one molecule of oxygen consists of 2 atoms, while one molecule of hydrogen consists of 2 atoms. One molecule of water consists of 3 atoms, 2 hydrogen atoms and 1 oxygen atom. Their subscripts cannot be changed. The subscript of H2 is 2. Subscript of O2 is 2. It can't be changed because the smallest part of hydrogen existing in nature is H2. You cannot find hydrogen atom lonely. It must be diatomic molecule. One molecule of hydrogen consists of 2 atoms. So H2 is the symbol of hydrogen. We cannot change the subscript 2. Also for oxygen, we cannot change the subscript 2. So what we can change to balance the number of atoms on the left side and on the right side of the chemical equation, we must change the coefficients. The coefficients are the numbers written on the left side of the formula of or of a symbol. The number written on the left side is called coefficient. Now, to balance this equation, we have on the left side, the reactant side, we have 2H and we have 2O. So on the product side, we have 2H and 1O. But on the left side, we have 2O. So we put big 2 on the left side of H2O. This big number, 2, is put to balance the oxygen. So 2 is multiplied with the hydrogen and multiplied with oxygen. So we have now 2 oxygen atoms on the right side. And on the left side, we have 2 oxygen. So now oxygen is balanced. But if we put the coefficient 2, it affects all things written after. So it will affect the number of hydrogen. So now we are going to correct the number of hydrogen on the left side. Here we have 2 times 2. It means 4 hydrogen atoms. So looking on the left side, we have 2H, 2 hydrogen atoms only. So we need to put 2 on the left side to balance the hydrogen atoms. So the result will be 2H2 plus O2 gives 2H2O. This is a balanced equation. Now we have, look at the left side, 2H2 means 2 times 2, 4. On the right side, 2 times 2, 4H. On the left side, 2O. On the right side, 2O. So we put 2 coefficients. The 2 at the beginning and the 2 on the water side. This is the balance of the equation. Let's watch another example. Nitrogen plus hydrogen gives ammonia. 1 molecule of ammonia consists of 1 nitrogen atom and 3 hydrogen atoms. Now, we are going to balance this equation. This equation is not balanced. We have 2 nitrogen on the left side. How can we convert the right side to be containing 2 nitrogen? As we said, we cannot change the subscript, because if you change the subscript, you are changing the identity of the substance and the properties of the substance. So we are not going to change the subscript. We are going to put 2 in front of ammonia. So it will be like this. It will be like this. 2 NH3 on the right side. 2 NH3. Okay, if we put this 2, will it affect another thing? Yes, it will affect the number of hydrogen atoms. So hydrogen atoms will be 2 times 3 means 6 hydrogen atoms. So now hydrogen is not balanced. Returning to the hydrogen on the left side to correct it, here we have H2. How can we change it to be 6H like that on the right side? On the right side we have, as we said, 2 times 3 means 6H. How can we change H2 to be 6H? What's the number we can multiply with 2? It will be 3. So putting 3 in front of H2, it will be 3H2 plus N2 gives 2NH2. N2 plus 3H2 gives 2NH3. This is the balanced equation. We have 2 nitrogen on the left side and we have 2 nitrogen on the right side. 3 times 2 hydrogen means 6 hydrogen. On the right side, 2 times 3 hydrogen means 6 hydrogen as well. Now this is a balanced equation. Let's move to the next example. Calcium phosphate plus sulfuric acid gives calcium sulfate plus phosphoric acid. Here, sulfuric acid is most stable, so it can produce phosphoric acid. It can produce phosphoric acid from calcium phosphate. Now, let's see how can we balance this equation. The subscript after the phosphate, PO4, 2. This 2 means that we have 2 phosphate ions. We have 2 phosphate ions, okay? So we can use this in the balance. So on the left side, we have 3 calcium and 2 phosphate ions, 2 hydrogen ions, and sulfate, SO4, sulfate, 1 sulfate. Let's move to the right side. We have 1 calcium, 1 sulfate, 3 hydrogen ions, and 1 phosphate ion. Now, how can we balance this? To balance this equation, we are going to look from calcium phosphate. This is the most complicated compound. We must start from the most complicated compound. Start your balance from the most and biggest compound. Okay? This will be better for you. Okay? Now, starting 3 calcium. So we put here 3. Let's look. It will be like this. 3 calcium sulfate. We put this 3 coefficient to balance the calcium ion, but it will affect sulfate. Now we have how many sulfate on the right side? 3 sulfate. So returning to the left side to balance sulfate. So it will be 3 H2SO4. This 3 affected also hydrogen. So we have 3 times 2 means 6 hydrogens. So we must put on the right side 2 to balance hydrogen ions. So it will be 2 phosphoric acid, 3 calcium sulfate, 3 sulfuric acid. If we put the last 2, this is the last 2, we are going to change phosphate. So what it will be? It will be 2 phosphate. On the right side, on the left side, it's also 2 phosphate. So we have here on the left side 2 phosphate, and we have on the right side 2 PO4, means 2 phosphate. So we have 2 phosphate on the left side and 2 phosphate on the right side. We have 3 sulfate on the right side, the product side, and we have 3 sulfate on the left side. 2 times 3H, 3 times 2H. 3 calcium, 3 calcium. So this is a balanced equation. Thank you for good listening and have a nice day and see you later, inshallah.